Hey everyone, welcome to our first section from Reasoning and Proof, and it's all about inductive reasoning and conjectures. Alright, so inductive reasoning is a type of reasoning that will help you get to proofs, and it's what we do a lot. So we as humans do this a lot. So let's just jump right in and talk about what inductive reasoning is. So inductive reasoning is really just the idea of looking at patterns and making a statement. So finding a pattern in a specific case, and then writing a conjecture about the general case. Alright, so you say, well, what's a conjecture? They do this a lot in science, and a conjecture is just an unproven statement that is based on observations. Alright, so we need to find a pattern for a specific case, and then we write a conjecture about this in the general form. Alright, and we just see if it works out. So let's look at some examples. Alright, so movie show times. Let's look at movie show times. And it says, write a conjecture that describes a pattern in the sequence, then use your conjecture to find the next item in the sequence. So movie show times are 8:30, 9:45, 11, 12:15. What would the next one be? Well, if I look at this, I know they're going up, and I think they're probably going up by some sort of addition. So how far is it from 8:30 to 9:45? It looks like it is, whoa, I don't want to do that. I want to use a different color here. That would probably be helpful. So I would say from 8:30 to 9:45 is about an hour and 15 minutes. If I go 9:45 to 11, is that also an hour and 15 minutes? And from here, is that also an hour and 15 minutes? Okay, so write a conjecture that describes the pattern. So what I'm going to do is I'm actually going to type this. Let's just go ahead and do this. I would say each movie time is 1 hour and 15 minutes after the last showing. Alright, so we have 1 hour and 15 minutes after the last showing, and then we can say, let's figure out when is the next one going to be. Well, it's 12:15 plus an hour 15, so the next one is going to be at 1:30. Okay, good. So let's do the next one, part B, 10, 4, -2, -8. So these are going down, it looks like, 10 to 4. So I'm going to say, I bet it's division. So let's just try something. I'd take 10 divided by 2 is 5 minus 1 equals 4. So I bet I'd take the number, divide by 2, and minus 1, and I get 4. So 4 divided by 2, let's see if that works. 4 divided by 2 minus 1 is going to be 2 minus 1, which is 1. And I don't get -2. So that doesn't look like it's a very good system. So I'm going to have to write a different conjecture because it didn't work out for all of them. So let's go back and try something else. Well, 10, 4, maybe instead of dividing, because 10 divided by something is 4, I don't really know what I'm dividing by. Multiplying by 10/4, I don't know, something like that. So I'm going to try subtraction. Well, 10 minus 6 would get me 4. 4 minus 6 is -2. -2 minus 6 is -8. Okay, well that seems to work with all the patterns that I have. So I would say take the previous number and subtract 6. And that seems to work out. Take the previous number, subtract 6. Okay, so then what would the next one be? Well, -8 minus 6 would be -14. Alright, so there is example 1. Now look at example 2. Make a conjecture about each value or geometric relationship. List or draw some examples to support your conjecture. So the sum of two odd numbers. I don't know what that is, but I can start to figure out if I take two odd numbers and see what happens. So if I do like 3 plus 5, I get 8. Alright, let's take 7 plus 9, and I get 16. Okay, what happens if I take 1 plus 3? I get 4. If I take 1 plus 7, I get 8. All of these numbers, 8, 16, 4, 8, they're all divisible by 4. That's kind of unique. What happens if I do like 7 plus 5? I get 12. That's divisible by 4. What about 7 plus 11? That is 18. That's not divisible by 4. Okay, so it's not divisible by 4, but if I say, 18 is divisible by 2, and they're all divisible by 2, which means they're all going to be even. So what I have is based on these examples that I've just said, I think that the sum of two odd numbers is even. Alright, so that's what I'm going to write right in here. I'm going to actually give myself some room, that way I can. So I'm going to say, the sum of two odd numbers is even. Alright, and there we go. The sum of two odd numbers is even. And I just gave some examples of where that might work out. Okay, so segments joining opposite vertices of a rectangle. Let's look at that one. So the first thing I'm going to try and do is I'm going to try and draw a rectangle. Alright, I'm going to draw it down here so I have room to write. So there's my rectangle. Okay, so now it says segments joining opposite vertices. So I'm going to go ahead and use a segment, and I'm going to draw a segment from here to here. There's one, and here's another one. Okay, well, looking at some of these things, they don't look like they're perpendicular. Right, they don't look like making them 90 degrees. Okay, that doesn't work. They look like they're the same length. That's for sure. Because it seems like I go left this many, up this many. I go right this many, up the same amount. It seems like they're probably going to be the same length based on just that one. So let's see if I get a different rectangle. Maybe that'll help out. So let's try one that looks very different from this one. If I go a rectangle like this. Alright, and then I'm going to have some segments that go in between them. And let's use a different color this time. Let's go here and say this one to this one. Now I go here and I'd say, do they look congruent? Man, they really do. So my conjecture is that segments joining the opposite vertices of a rectangle are congruent. So that's what I'm going to say. And that seems to really be correct based on what I've seen. Right? Alright, good. So there is example 2. And then let's go to this last one. Let's talk about a counterexample. So what is a counterexample? And a counterexample is a specific case in which the conjecture is false. Alright, so example 4. Find a counterexample to show the conjecture is false. If n is a real number, then n squared is greater than n. Alright, well, what happens if we have n equals 0.5? What happens then? If I take 0.5 squared, it's going to be 0.5 times 0.5, which is 0.25, and 0.25 is less than 0.5, which makes this not true because n squared has to be greater than n, and this is n squared, and this is n, and it's not greater than. We have a problem. So here is an example where n equals 0.5, that this makes this whole thing not true. So here is a counterexample. Let's look at B. It says, if jk equals kl, k is the midpoint of jl. Well, that's not necessarily true. But if a segment looks like this, jk, and I have kl. And since I'm sketching, let's say this one is congruent. So I have j, k, and l. Well, they're not the midpoint, but they are congruent. So this would be a counterexample of that one. Alright, and part C, if n is a real number, then negative n is negative. Well, what happens if n is negative 5? Then we have negative 5, which is positive 5. So, there's a counterexample, negative 5. It's not the only one, but it is one. So, there you go. There are your notes.